Hey everyone, so you're interested in learning about logarithms. You have little to no basic understanding of this concept. Well, in this video, I'm going to go through some of those basic concepts to help you understand what logarithms are. And in the video, I'm also going to show you the connection between logarithms and exponents and radicals. If you have a little bit of basic knowledge on what logarithms are, but you want to know the different laws and properties of logarithms, then click on this link up here. Now, on the other hand, if you know the laws and properties of logarithms, but you want to see some applications of logarithms in real life, then click this other link up here. Otherwise, if you're new to this topic, keep watching this video and I'm going to show you what logarithms are all about. My name is Peter. Grab a calculator and let's get started. So let's start off the video by looking at the definitions of exponents and logarithms. In this video, I'm going to be using the word exponents, indices, and powers interchangeably because they all mean the same thing. What are indices? Indices are just representations of repeated multiplication. So if you have, let's say, the letter A and you're multiplying it times A times A times A, B times, then you can simplify this repeated multiplication using this notation. A is going to be the base. This is the letter that is repeating. And B is a small number that's written up here, represents the number of times you're repeating A. We give B the special name power or index or exponent. Exponents and logarithms are related concepts. But before we look at what are logarithms, let's first of all think about a concept in mathematics known as inverses. Once we understand that, then we'll see the relationship with logarithms. Inverse operations exist in mathematics to undo or reverse math operations. They play a key role in going backwards and figuring out what we had at the beginning of a math problem. So addition and subtraction, those two functions are inverse operations. That means if you want to undo addition, use subtraction. If you want to undo multiplication, use division, and vice versa. So here's an example. You have 5 plus 3 equals to 8, and if you have the result 8, but you don't have the initial number here, all you need to do is to figure out what is the inverse of plus, and it's subtraction. So you would subtract 8 minus 3. Same thing with multiplication and division. If you multiply 5 times 3, you get 15. If you have the result of 15, but you're missing the initial number, all you gotta do is to figure out what's the inverse function of multiplication. It's division. 15 divided by 3 will give you 5, which was the initial number. The concept of inverse operations can be extended to exponents. In this part of the video, I want to explain why. So the first thing is to recognize that exponents have an inverse operation, and this inverse operation can be seen in two ways. One is through radicals, and the second way is through logarithms. So the first way through radicals, let's say you have a number 5 cubed is equal to, and you want to know what the result is. 5 cubed means that you're multiplying 5 times 5 times 5, which equals to 125. So if you want to know the inverse, you want to go backwards and figure out what number do I multiply 3 times to get 125, then you would need to take the cube root. So the cube root of 125 equals to 5. In other words, whenever you take the radical, you're actually looking for the base of that exponent. Now, the other way that the inverse of exponents is using logarithms. So let's say you have a number 5 raised to an exponent x, and it gives you a result of 125. So you want to figure out what is the exponent that gives you 125. So in this case, you would take the logarithm of 125 to base 5. So the logarithm would give you 3. What this means is if you take 5 to the power of 3, you're going to get 125. Whenever you do this, whenever you use logarithms, you're actually looking for an exponent. This is a really important distinction between radicals and logarithms. So logarithms are the inverse of exponents, or logarithms are actually exponents in that you're looking for the exponent of that exponential function. So now that we know the why, now let's take a look at the how. How do we find logarithms? And to do this, let's start with a formal definition. The log, this is a short form of logarithms, the log of base b of x is equal to y. And y here we know is the exponent. So if and only if x is equal to the base b raised to the power of the exponent y, where b is a positive number. So the way you read this part here is log base b of x. We have the base of x and we're looking for the exponent. The first example we're going to look at involving logarithms is going to be a math problem that has a base 10. So if you want to rewrite logarithms in exponential form, you would use this definition that we had at the beginning. So let's take a look at a first example here. And this is going to be logarithms with a base 10. So we're going to use the definition that I gave a few seconds ago. And our example starts off with the number 100. How can we rewrite 100 in exponential form? It's going to be simply 10 squared. Remember, our base is 10. That's why I'm writing 10 squared. If you want to rewrite this using logarithms, then this would be log base 10 of 100. And if you know that it's 100, then what is the exponent that gives us 100? The exponent is 2. So in this way, we have rewritten the exponential form in logarithmic form. Let's try a second example where we have logarithms that have a base 3. So in this example, we have 81 equals to 3 to the power of 4. How can we rewrite this using logarithms? Really easy. So the first thing is we write log, and then our base is 3 of 81. So what is the exponent that gives us 81 if the base is 3? And the answer is equal to 4. Let's try a different aspect of solving this math problem. So let's imagine you're given the logarithm form of an expression. Logarithm base 2 of 8 is equal to 3. So you want to rewrite this logarithm in the exponential form. So how would that look like? So the first thing, the 8 here, our result, is going to be equal to the base. Our base is 2, and then we need to figure out what is the exponent of base 2 that gives us 8. So you would have to multiply the number 2 3 times to get 8. 2 times 2 times 2, and that means the exponent is going to be 3. Here's another example with a base 2. So in this case, we have 1 over 8 is equal to 2 to the power of negative 3. So the exponent is a negative number. So we're going to write the exponential form in logarithm form, and that's going to be log base 2 of 1 over 8. And so we want to know what is the exponent of 2 that gives us a fraction, and that's going to be negative 3. The following exercises, we need to evaluate the logarithms. And we're going to evaluate them by rewriting each logarithm in the exponential form. So the exponential form is x is equal to the base raised to an exponent y. In the first question, we have log base 4 of 16. So we want to figure out what is the exponent of base 4 that gives us 16. So we're going to set this logarithm equal to y, and then we're going to rewrite it in the exponential form as 16 is equal to 4 raised to the power y. So what is the y value that gives us 16? It's going to be y equals to 2. 4 squared equals to 16. The second math problem, we're going to set it equal to y, rewrite it as an exponent in the exponential form. 27 is equal to 3 to the power of y. What is the exponent of 3 that gives us 27? Y equals to 3. 3 cubed equals to 27. The third problem, we start off by setting it equal to y, and then we have 49 is equal to 7 raised to the power of y. What is the y value? Well, in this case, y is going to be equal to 2. 7 squared is equal to 49. The last math problem has a fraction, so we're going to write the fraction 1 over 49 is equal to 7 to the power of y. Y in this case cannot be a positive number. If it's a positive number, then we're not going to get a fraction. So the only way we'll get a fraction is if the exponent is actually a negative number, and it's negative 2. Here's a quick pro tip. Logarithms are just exponents. We use logarithms to write exponents in just a different way. If you're trying to solve a math problem that has an unknown exponent, you can use logarithms to figure out what that exponent is. And that's your pro tip. Let's finish up today's video with some independent exercises. There are 4 questions based on the exercises that we did in today's video. The 4th question has a special treat. It's extra challenging. If you need the answers to all the 4 questions, they're in the description box below. Good luck!